Hi, hello everyone. Welcome back to the Daridipa YouTube channel. Dear students, in the previous class we have discussed about the chemical reactions and chemical equations. And also we have studied about the balancing equation. Before going to the next concept, just we can revise how to balance the equation. One or two equation I will show you how to balance. Later we can go to the next topic, types of chemical reactions. See here, I have written one equation, that is Fe plus H2O gives Fe3O4 plus H2. In this equation, just you observe that whether the equation is balanced or not. First we should check that. Before balancing the equations, as I said that first it should be checked whether it is balanced or not. If it is balanced, no need to balance again. You have to write the same equation as it is balanced. Just you observe here, in the left hand side, observe that how many iron atoms are there. Here 1 iron atoms are there and 2 hydrogen atoms are there and 1 oxygen atom is there. The reactants are what? Iron and water. Fe means iron and water reacting here, so they are called as reactants. In these two reactants, how many atoms are there? Iron 1 atom, hydrogen 2 atoms, oxygen 1. Look at the right hand side of the equation, means the product side. You can observe there. Here iron atoms are 3, see there, and oxygen atoms are 4, hydrogen atoms are 2. Now you see there, how many iron atoms here? 1, here 3. It is not balanced. The equation is not balanced. We need to balance that. As I said that here there is no any rule to balance. We have to follow some of the steps. How we are balancing the equation? Why do we need to balance the equation? As we have discussed that according to the law of conservation of mass, the equation must be balanced. Means the mass of the reactants should be equal to the mass of the products after chemical reaction. During chemical reaction, mass is neither be created nor be destroyed. So here you see that iron atom is only 1, here 3 are there. So it is not balanced. We need to balance that. So when we are balancing, we must know that we are not supposed to write any number in between the elements in a compound. Here there is one compound. In between these two elements, you are not supposed to write. In the beginning of the element means in this position or in this place, you should write that number. What you are going to add number, you must write in these places only. You are not supposed to write in between the elements in a compound. See, or you are not supposed to write here also 2Fe like that. You are not supposed to write. See now, in the left hand side 1 iron, here right hand side 3 are there. It should be done 3. What to be done? 3. So how can we write? The 3 is not supposed to write here. It should be written here. You are not supposed to write here anywhere. Before the compound or before the element, number should be written. Now see there, iron became 3. Iron is balanced. Now we look at the hydrogen. Here hydrogen 2 are there. Here also 2, no problem. Oxygen you see there. Here 1 is there. Here 4 oxygen atoms are there. Oxygen must be balanced. Here 1, here 4. Now what to be done? This here also it should be done 4. Then what happens here? We need to write 4 where you are not supposed to write here. In between the elements also you are not supposed to write. Where? Here you must write 4. Now you look. See 4 oxygen. When you write the 4 here, number of hydrogen also changed. See there, 4 2s are 8. Hydrogen became 8. Number of hydrogen atoms in the reactant side became 8. So again we need to balance. Oxygen is balanced. Hydrogen should be balanced. Now here 8, here only 2. This should be done 8. How to make that? Here if you write 8 means 8 2s are 16 it became. But you are not supposed to write 8 here. See, when you write 4, 4 2s are 8. Balanced. Now see that hydrogen is also balanced. Now the equation is finally balanced. This is what we call it as balancing the equation. Hope you have understood. Suppose if there is an equation like this, CaCO3 gives CaO plus CO2. Here reactant is only 1, but products are 2. If you are asked to balance this equation, you check that whether the equation is balanced or not. Before balancing, you must check that. Now see there, calcium is 1 here, here also 1. Carbon is 1 here, here also carbon 1. Oxygen 3 are there, here also 3. See that here 1 is there, here 2, 3. Equation is balanced, no need to balance again. So this is what, there are several equations in your syllabus, SSLC chemistry book or chemistry part. You observe that many equations are there. You just try to balance them. What are the equations are given at the end of the lesson as a text questions. You just balance that. If you have any doubts, you just drop the message in a comment box. We can rectify or we can clarify your problems in the next classes. If you get any doubts related to the balancing equation, just drop a message in the comment box. We will clarify your problems in the next classes. Hope you have understood about the balancing equation. Next we can discuss about the types of chemical reactions. Students, now we are discussing about the types of chemical reactions. The chemical reactions are mainly classified into 4 types. Which are those? The first one is combination reaction. Combination reaction. Then second one is decomposition reaction. Decomposition reaction. Displacement reactions. And fourth one is double displacement reaction. Double displacement reaction. These are the main 4 types of chemical reactions. Some other chemical reactions are there: endothermic, exothermic, neutralization, oxidation, reduction, that we can discuss later. After studying about these 4 types of reactions, we can discuss about the endothermic, exothermic as well as oxidation, reduction, neutralization, precipitation reactions. Mainly the chemical reactions are classified into 4 types. First one is combination reaction. First we can discuss about the combination reaction. Later we can go to the next type of reaction. Combination reaction, as it says, the name says that combining, combination. See that combining means what happens here? It is a type of chemical reaction in which 2 or more reactants combine to form a single product. Means here it is a one substance. Here this is the one substance. These 2 substances react each other or combine each other to form a single substance. This is called as combination reaction. They are combined. So we can easily, this is not a chemical equation, just I have given the example by taking XY. There is no any element XY or any compound XY in the chemistry. Please note that. It is an example to show you. Here 2 substances are combining to form a single product. For example, carbon reacts with the oxygen to give carbon dioxide. Hydrogen combines with the oxygen to form water. These 2 equations you observe that calcium oxide reacts with the water or combines with the water, forms the calcium hydroxide. Calcium hydroxide. These are the equations or the examples of combination reactions. See there, in these reactions 2 or more than 2 substances or the reactants are reacting each other to form a single product. See that we are seeing the single product here. One product we are getting. This is called as combination reaction. So how to write the definition of combination reaction? Combination reaction is the type of chemical reaction in which 2 or more substances react each other or combine each other to form a single product. Hope you have understood. So examples you can give that. Easy example you can write that. Carbon reacts with oxygen to form carbon dioxide. Hydrogen and oxygen reacting each other to form water. Calcium oxide, when it is dissolved in water or when it is reacted with the water, gives the calcium hydroxide. So this is one of the important equation. So in many question paper about this equation, many applied questions are asked. So just I will revise that. The equation, that is what, calcium oxide react with the water gives calcium hydroxide. Calcium hydroxide. See that what is meant by calcium oxide? Calcium oxide means quicklime. Quicklime means lime powder. You might have seen that in the schools. We are using the lime powder to put the tracks in during the sports and all. So that is called as quicklime. Quicklime powder, it is calcium oxide. When this quicklime is taken in a water container, or when it is added with water, or water is added to the quicklime, we are getting the solution that is called as calcium hydroxide. Calcium hydroxide. It can also be called as a slaked lime. Slaked lime. So what are the questions asked here? Applied questions. This, where do we use this slaked lime? This slaked lime is using in the whitewashing the walls. We are using the slaked lime, that is what calcium hydroxide is used for whitewashing the walls. You might have seen that the whitewashing, we are using what, calcium hydroxide, that is called a slaked lime. Means quicklime is added to the water to form the slaked lime, that is calcium hydroxide, which will be pasted on the walls to whitewash. See, when this calcium hydroxide is applied on the walls, suddenly it doesn't get the white color. After few minutes, as it get dried up, it started to shine up as a white. What is the reason behind this? See, when the calcium hydroxide is whitewashed on the wall, it reacts with the carbon dioxide present in the atmosphere, forms the calcium carbonate. What is formed? Calcium carbonate is formed, and water is evaporated. Means water is evolved as a gas. Here calcium carbonate is formed. What is formed? Calcium carbonate is formed. This calcium carbonate gives the white appearance on the walls. So here see that when calcium hydroxide is pasted or the used while whitewashing, after whitewashing, the calcium hydroxide means slaked lime react with the carbon dioxide present in the atmosphere, forms the calcium carbonate, which gives the white color to the wall. So this became, and one more I can give the example here. When you have taken the calcium hydroxide, means the water is taken in a container and calcium oxide, quicklime, is added to it. It became a solution that is called as calcium hydroxide or slaked lime. If you have taken a straw and you are blowing the carbon dioxide, means we are breathing out carbon dioxide. If you are going to add this carbon dioxide gas to the calcium hydroxide, same reaction takes place. This slaked lime gives the milky appearance, means it gets the milkiness, means white color it gets because of due to the formation of calcium carbonate. Suppose if you are continuing this process, continuously you are adding the carbon dioxide or you are blowing the carbon dioxide into this carbon dioxide again reacts with the excess of carbon dioxide, reacts with the calcium carbonate, forms the calcium bicarbonate, again this milkiness disappears. I will clarify once again. When you are blowing the carbon dioxide to the calcium hydroxide, it forms the calcium carbonate and gives the milkiness to this. If you are continuously blowing, what happens? The excessive carbon dioxide reacts with the calcium carbonate which is already formed and form the calcium bicarbonate and the milkiness disappears. Question can be asked. How question can be asked? You know that. What happens when carbon dioxide is added to the calcium hydroxide or slaked lime? What happens when carbon dioxide is added, or if you blow the carbon dioxide to the slaked lime, what happens? It forms the calcium carbonate, milkiness appears. It forms the milkiness. If you blow excess carbon dioxide, what happens? Milkiness disappears due to the formation of calcium bicarbonate. CaHCO3 twice, we say that. Okay. Calcium bicarbonate will be formed, which disappears the milkiness. So that this is applied question. Question can be asked here. why the calcium hydroxide is used for whitewashing? Because when calcium hydroxide is used in whitewashing, it reacts with the carbon dioxide present in the atmosphere, gives the milkiness, means white color. So these questions can be asked. Hope you have understood. So these are the examples of combination reaction, means two reactants combining or reacting each other to form a single product. Next type is decomposition reaction. Second type is decomposition reaction. This is the opposite of combination. Opposite, you know that, you might have heard the opposite: combine, decompose. Compose, decompose. Composing means combining. Combining, decomposing. It is opposite. How do we say that here? See there, what we said, that in the combination reaction, two or more reactants combining or reacting each other to form a single product. But in the decomposition reaction, opposite of that. Single reactant breaks down into two or more products. This is opposite, entirely opposite it is. Here two reactants are there, one product is there, but here one reactant, two or more products. This is decomposition. This is excellent. As I said that it is just for your sake I have given. One example I will give you. Calcium carbonate, as I said that. When calcium carbonate is heated, the symbol you might have seen. This is the symbol of heating, means energy we are giving. Energy. See here, when calcium carbonate is heated, we are getting calcium oxide with the carbon dioxide. See here, one reactant, two products. Products are two. Here one, here one. Two products are there. Reactant is one. This is decomposition. Means one substance is getting decomposed into two or more. Sometimes it is more than two in some reactions. For example, one more I will give. FeSO4, you might have heard. Ferrous sulfate. When ferrous sulfate is heated, it decomposes into Fe2O3 plus SO2 plus SO3. See here, one reactant, two or more products. Three products are there. This is called as decomposition. Single reactant breaks down into two or more. Such examples you can give that. Even water example also you can give. Water decomposes into hydrogen and oxygen in the presence of electricity. Here we are not heating. When you heat the water, we are not getting hydrogen and oxygen. When the electrolytic method we are following here, this is one type of decomposition reaction only. When water decomposes into hydrogen and oxygen, it is the example to show the decomposition. If you have written reverse here, H2 plus O2 gives H2O, this is combination. Sometimes this question is asked. How do you prove that? Or give some examples to show that combination reaction is opposite of decomposition reaction. Such questions are asked. So nowadays what happens, you know that direct questions are asking very rare. Applied questions. The questions are asked indirectly, related to the syllabus only. So that such questions can be asked. So a single reactant, many products means decomposition. How to write the definition? It is a type of chemical reaction in which the single reactant breaks down into two or more substances or two or more products. This is called as decomposition reaction. In this decomposition reaction, there are three types are there. How many types are there? Three types are there. Which are those? Thermal decomposition reaction, and second type is electrolytic decomposition reaction, and third one is photolytic decomposition reaction. These are the types of decomposition reaction. What is that first one? Thermal decomposition. Therm, the word itself says that. Therm, you might have heard this word, thermometer, thermal scanner, we can say that, and thermos flask, you might have heard that. Therm means heat. What is this here? Thermal decomposition is a type of decomposition reaction in which single reactant breaks down into two or more substances by heat. By heat. When you are giving the heat to, if you give the heat to the chemical reaction, means if you are heating the reactant, it breaks down into two or more substances. Then it is called as thermal decomposition. It is a type of decomposition reaction in which single reactant breaks down into two or more substances by heat. This is thermal decomposition. One more I had given there. Ferrous sulfate, iron sulfate means FeSO4 gives Fe2O3 plus SO2 plus SO3. Or when lead nitrate is heated, we get some other products there. These are the examples for thermal decomposition, means heat. Second one is electrolytic. This is also type of decomposition reaction where single reactant breaks down into two or more products by means of electricity. Here electricity is the energy. We are giving the energy in the form of different ways. Here thermal energy, here electric energy. Water is decomposing into hydrogen and oxygen. You might have seen that such symbols in the chemical equations. These equations, upward arrow mark equations, arrow marks. Upward arrow marks shows that they are evolving as a gas. Hydrogen and oxygen gases are evolving when the water is under the hydrolysis process. This is hydrolysis of water, we can say that. There is one diagram in your textbook related to the hydrolysis of water. I will explain later separately with a diagram what is meant by hydrolysis of water and what are the products here, hydrogen and oxygen, in what ratio they are evolving, and how to conduct such experiment I will explain with the diagram later. This is an example for the electrolytic decomposition, type of chemical reaction or type of decomposition reaction where single reactant breaks down into two or more products by means of electricity. And at last, the third type of decomposition reaction is photolytic decomposition. What is meant by it? Here, the single reactant in all the three these all three are decomposition reactions only. Here, single reactant breaks down into two or more products by means of electricity here. Here, thermal energy. What about here? Photo. Photo means not taking the photo. Photo means it is sunlight. Sunlight means by using solar energy. This is an example of photolytic. What is meant by photolytic decomposition? Type of decomposition reaction in which single reactant breaks down into two or more substances by using sunlight. This is not a balanced equation. We can balance it easily. See that two chlorine atoms, now two became two silver. AgCl means silver chloride. Silver chloride, when it is kept in sunlight, we are getting the silver and chlorine gas. If silver bromide, AgBr, this also gives Ag and Br2. These are the examples of photolytic decomposition. Sunlight is the energy for these chemical reactions. And here, many times this about the photolytic reaction, applied questions are asked. How these reactions, these photolytic reactions such as AgCl or AgBr decomposition is used in black and white photography. Which reactions are used in black and white photography means you must write this photolytic reaction. And one question is asked, I think last year or 2 years back. What is that? What happens when the silver chloride is kept in sunlight? What happens when silver chloride is kept in sunlight? What happens when silver chloride is kept in sunlight? What is produced? Silver and chlorine gas is developed. So sometimes question asked, you are not supposed to keep the silver chloride, or we are not supposed to keep the silver chloride in sunlight. Give reason. Justify the statement. Because where photolytic decomposition takes place, so that what happens then? These products are produced, silver and chlorine. So we are not supposed to keep the silver chloride in the sunlight. I hope you have understood the three types of decomposition reaction. electrolytic, as I said that I am going to explain this hydrolysis of water, how water is going to be distributed as a hydrogen and or how it is going to be decomposed into hydrogen and oxygen by electric method. You can see that. And next, third type of chemical reaction is